Hello, boys and girls. So today we are doing lesson 6.4. We're going to be looking at factors. But before we start the lesson, I also want to touch on the mathematical practice that we will be looking at today. Today we will be looking at mathematical practice 1. What is the mathematical practice? It's a way that we solve problems, skills that we need. Mathematical practice 1 says we're going to make sense of problems and persevere in solving them. So that's what we're going to do today. We're going to make sense of the problem and we're going to persevere. What does persevere mean? It means that we will work continuously without giving up until we figure out how to solve the problem. All right, let's go ahead and get started. So for lesson 6.4, we will be looking at page number 265. We are on lesson 6.4 and we're looking at factors. So to begin with, remember we always write our objective up here. I will also provide that in the slide. The objective for this lesson is we will express a whole number in the range 2 to 50 as a product of its prime factors. So the essential question is, how can you write a whole number as a product of its prime factors? The first thing that we want to analyze is, what does factors mean? So when we're talking about factors, we're talking about multiplication. These are the numbers that we multiply together to get a product. The product is the answer to a multiplication problem. So here we have factors are numbers that are multiplied to form a product. 2 and 3 are factors of 6 because 2 times 3 equals 6. So the numbers between the multiplication sign are the factors. And after the equal sign, we have the product, which is the answer to the multiplication problem. Now, that is one word that we just went over, a vocabulary word, which is factor. Now let's look at what prime number is. A prime number, so this is where you might want to highlight this in your book. A prime, wait, I'm not even highlighting. This is not the right one. Okay, so a prime number is a whole number greater than 1 that has exactly 2 factors, 1 and itself. And we already spoke about this in class, what that means. But just in case you don't remember that there are 2 types of numbers. There's the prime number and the composite numbers. Composite numbers are numbers that have more than 2 factors. Prime number only have 2. 1 and itself. Okay, for example, 7 has only 2 factors, 1 and 7. You cannot make 7 multiplying any other digits. 2 times 3 is 6. So you can do 2. 3 times something does not give you 7. 4 times something does not give you 7. 5 times something doesn't give you 7. It's only 1 and 7. So this is a prime number because it only has 2 factors, 1 and itself. Okay. So we explore what a prime number is. A prime number only has 2 factors, 1 in itself. A composite number, however, is a whole number greater than 1 that has more than 2 factors. So it's not only 1 and itself, but it has additional factors. A composite number can be written as a product of its prime factors. What does that mean? That you can you can write it with multiplying its prime factors. Like you can break it out. So that's what we're going to be looking at today. And 2 times 3 equals 6. 6 is a composite number because the factors of 6 are 1, 2, 3, and 6. So it has 4 factors. I mean, it's a composite number. Okay, let's go ahead and unlock the problem, and then we will be exploring or looking at factors. Remember, when we are looking at word problem, we want to make sure that we have a highlighter in handy or a pen to underline. Let's read the problem. Marcel makes a mathematical pattern in his painting with vertical stripes. Vertical means it's going from up down. For his next painting, each stripe will be the width in inches of one of its prime factors of the total width of the painting. He wants this painting to have a width of 20 inches. Marcel needs to determine all the prime factors of 20. And so this is what he's trying to find. This is what he needs. He needs to determine all the prime factors of 20. So he will know the width of each stripe. And now the question is, what are we trying to find? We are trying to find what are the prime factors of 20. Really, that's all the information relevant that I need. I just want to know what are the prime factors of 20. So we're going to make a list to find the factors. Okay. So here's where we just start. This is where you need to know your times tables, because that way it'll be easier for you. So we want to list of pairs of factors to form 20. And so here they started it for you. You want to start with 1, and it's the number itself always, because you know that for sure that is, if those are the two first factors that all numbers have, 1 and the number itself. So 1 times 20 equals 20. Now we want to move up. Okay. And another way that I've been showing you how to do this is what I call the rainbow. I put my the number here in the middle. Let's see, 20, right? And then I start with 1 and the number itself, 1 and 20. Those are my two first factors. Then I'm going to go to the next number, which is 2. Well, first I think in my head, can I multiply 2 times something to get 20? Yes, right? 2 times 10. So 10 is another factor. Then I think, can I multiply 3 times something to get 20? Well, 3 times 7 is 21. It goes too high. So I don't think I can. So then I go to the next number, which is 4. 4 times what number will give me 20? 4 times 5. Now, if you notice, 4 and 5 are next to each other. 4 and 5. So that means that that's my last factors, 4 and 5. Because the next number is 5, and it just keeps repeating itself. So I have a total, and I forgot to put the line here. The reason why I call it a rainbow is because, it looks like a rainbow. We're going pairing up the factors. So I had, so these were my multiples. 1 times 20, my factors, I'm sorry. 1 times 20, 2 times 10, 4 times 5. So the factors of 20 are, and now what I'm going to do here, I'm going to list them in order. We need to list these in order. So I start with 1, right? And I can just look down, or just look here in my rainbow. 1, 2, then I have 4, then I have 5, then I have 10, and I have 20. So there I just modeled you and showed you how I find my factors for 20. Now, this is some of the type of questions that I've given you on the quiz, on the weekly quizzes. So now once you learn this and you know how to do it, now it says find which of the factors of 20 are prime. So this is where now we're going to keep going, because we want to find the prime factors. So we already know what are factors. These are all factors. Now we want to find the prime. And remember, prime is numbers that that are composed of only 2 factors, 1 and itself. Like 7, only 1 times 7 will give me 7. So which of these numbers are prime numbers? So which of these factors are prime? So you ask yourself, does 1 have exactly 2 factors? Well, one times, you can only make one by multiplying one times one. Um, so one is not actually considered, um, or we will not even use it. We don't use one as a prime factor because it does not have two factors. It only has one. Yes, you're probably thinking, what, Miss Maldonado? I don't get it. Yes, it only has, it has exactly, a prime number needs to have exactly two factors, one and itself. But for one times one equals one, it's only one different digit. So it doesn't have two factors, it's just one. Okay, well, let's keep going. Now we're going to repeat the same. We're going to ask ourselves, does so and so number have two factors? And we're going to circle the prime factors. So we already know that it's not one. What about two? Well, we can only make two by multiplying one times two. Therefore, two is a prime factor. So we will circle it. What about four? Think about it. Four. How do we make four? Well, 1 times 4 is 4, but then 2 times 2 is 4. So it has three factors. So that wouldn't be it. What about 5? 1 times 5 equals 5. 2 times something will give me 5? No. 3 times something will give me 5? No. 4 times something? No. So it only has two factors, 1 and 5. And then we know that 10 has more than two factors, 1, 2, 5, 10. And 20 has more than two factors. So that means that my prime factors of 20 are 2 and 5. Those are my prime factors. Okay, so now we're going to do some examples. And now we're going to use a diagram. And I actually like this way. I just think it's fun. It just be my mathematical mind that likes it. So here we have an example. Dion has forgotten the code of her locker. She remembers that the four one-digit numbers in the code show 36 written as a product of its prime factors. Like, come on, who will know, right? Who will remember the prime factors? I don't know. I think that's odd. But anyway, what are the numbers in Dion's code? So we're trying to find Dion's code. We know that 36 is the product of its prime factors. What does that mean? That you multiply all the numbers and it'll give you 36. All the prime numbers and it'll give you 36. So we're going to start off with 36. And what we're going to do is that we're going to finding factors until we have all prime numbers. So what we want to do is we start off by, this is 36, the number we're factoring out. And we think of two, we're going to find two factors. That's all we're going to do first. Find the first two factors. How can we make 36? So here they started it off for us. So 6 times what number equals 36? Well, 6 times 6, right? If you know your times tables, you know that 6 times 6 is 36. So I'm gonna write 36 and I'm gonna put two lines, like if it's branching out. I'm writing 6 on one side and 6 on the other. Okay. Now I'm gonna repeat this process. Now I'm gonna find the factors of 6, and I'm gonna stop until I have all prime numbers. Okay, remember, prime numbers are numbers that only have two. Prime numbers are numbers that only have two factors, one and itself. 6 is not a prime number; it's a composite because I can make 6 by multiplying 2 times 3, right? So they already gave us a 2. I know that 2 times 3 equals 6, and 6. I have a 6 here again, so I know it's the same thing. 2 times 3. So my prime factors with the S at the end is 2, 3, 2, and 3. That means that when I multiply all these numbers together, I will get 36. So 36 is equal to 2 times 3 times 2 times 3. Actually, it's better if we put these in, well, actually it's fine. So that this is what I will say it's my my prime factors. Because 2 is a prime number. You can only multiply 1 times 2. 3 is a prime number because I can only multiply 1 times 3 to get 3. And then they repeat. So what are the prime factors of 36? It's 2 and 3 because those are the numbers that we're using, 2s and 3s. Now the when the question is asking you to write what's the product of its, what are the factors, the prime factors, and you write all the repeated numbers. Okay, let's look at B. This is very important that you look at this and you can visualize this. The divisibility rule. What is a divisibility rule? It means that I know that if the number is even, means that it ends with 2, 4, 6, 8, 10, then I can divide by 2, right? So in 36 is an even number. So I use my divisibility rule. So I know that I can, the 2 factors, I can definitely have a 2 as a factor. So 2 times what number equals 36? So I could have gone 2 times 18, right? 2 times 18 is 36. So in this case, where 2 is my prime number, I just keep the 2 going. Okay, that will be one of my factors. Now I need to factor out 18. Okay, so what 2 factors make 18? Remember, here we don't use 1. Because 1 is not a prime number. So we don't try to, we don't do 1 times 36. It has to be numbers that do not include 1. No 1 factors. Okay, so 18. 2 times what? Well, I know I can factor, one of the factors could be a 2 because 18 is an even number. So 2 times what number equals 18? Well, 9, right? 2 times 9 is equal 18. So I'm carrying down my 2. Now 9 is not an even number, but I know that 3 times 3 equals 9. So those are my last 2. So here 36 written as a product of its prime factors. Okay, when a question is asking you to write a number as a product, okay, that means as a product means that as we're multiplying its prime factors, then what it means is that we're writing all the prime numbers. 2 times 2 times 3 times 3. Basically, it's just this bottom row. And so the answer is 2 times 2 times 3 times 3. Okay. So here are some sample problems. I'm going to give you one as an example, and then you will have to answer some of these in the Google slide. So the lesson is actually not over until you have completed all the exercises that I give you on the slideshow. Okay, so I'm going to give an example and then you will get to try it. Okay, I'll give you 2 examples and then you get to try it on the Google slide. So we're going to find the prime factors of 27. And so you can branch it out because they all need to be prime numbers. So all the numbers that you give me, that you list, they need to be prime numbers. So what I'm going to do is that I'm going to write 27 here, and then I'm going to think about two factors that make 27. So 2 numbers that when you multiply them together will give you 27. I know, 3 and 9, right? Now, if you have a prime number, I recommend that you just circle it. So you know that that's going to be one of your digits. 3 is a prime number because you can only multiply 1 and 3 to get 3. However, 9 is not because you can do 1 times 9, but you can also multiply 3 times 3. So here I'm going to write the factors that it's not include 1 and itself. So it's 3 and 3. So 3 is a prime number, 3 is a prime number. So my answer here would be 3 times 3 times 3. And those are my prime factors. Okay, let's do one more. Number 2. So I have here 28. And I'm going to write. Now here I can use my divisibility rule, which means it's an even number. So I know that I can I know that 2 times a number will give me 28. So 2 times what number will give me 28? Hmm. We'll just break it in half, right? So half of 28 is 14. Now 2 is a prime number. So I'm going to circle it because I know this is going to be one of my um, factors in my answer. So now 14. Now 14 is an even number. So again, I can apply the divisibility rule, meaning that I will use 2 as one of my factors. And I think, okay, 2 times what number equals 14? Well, think, what is half of 14? 7, right? So here I know that 2 is a um, 2 is a prime number because I can only make 2 by multiplying 1 and 2. Now, 7 is 7 a prime number? And you can list the factors. 1 times 7 is 7. 2 times, so 1 and 7, right? Now, oops, that does not look like a 7. Okay. You can write them on the side if that helps you. Okay. But I know 1 and 7. Now, 2 times the number gives me 7. No. 3 times the number? No. 4 times the number? 5? No. 6? No. So that means that it only has these two factors. So it's a prime number. So that's the end. Okay. I reach a dead end. I can't break any of the factors anymore. So here my answer would be, okay, what are the prime factors? You can list 2 and 7. Now, my factors are 2 and 7 because 2 repeats itself. But if the question is asking you to write it as a product of its prime factors, that means that you're writing the sentence with, the multiplication sentence. So that would be 2 times 2 times 7. Okay. Either or how answers I will accept. They would be correct. Okay. But you just got to remember that if it says to write the number as the product of its prime factors, that means you need to write it out like this because you're writing the number as a product. Product means multiplication sentence. It's an answer, a multiplication answer. Okay. All right. So go on to the next slide for the problem that you will do on your own.